Hi, good morning. Today in aerodynamics of solids, we are going to see the types of structural elements which is we are seeing in our day-to-day life. So we have the general types of structural elements. That is a bar element, beam element, frame element, spring element, and column, right? Column element. So these are the general structural element which is existing in the internal around what we are seeing here. We are in buildings, aircraft wings, and in automobile sectors like car, bike, right? So what is going to be a bar element? What is the bar element?
Bar is the horizontal member.
Bar is the horizontal member.
Taking the loads resisting the bending.
Resisting the bending. What is the beam element?
Beam is the vertical. Vertical component. It's supported by the columns.
Okay. What is the frame element?
Frame is the supporting element.
Okay. What is the spring element?
We have there are two types of spring elements there, closed and open. And both serves as different types, like one is for compression and another is for tension.
Okay. What is column?
Supporting component.
Okay, sir. So you have your own opinion. We'll have understand what was seen based on the definition. We'll have some the models which you have in your tables, right? With that, we'll understand what is this actually, right? First, we'll go for a beam element, a bar element. So this is the bar element, right? This is a bar element, which is not supported by any other elements, right? Bar element is carries the only axial load. This is a one-dimensional bar element, which will take only axial tension and compression load, right? Axial tension as well as compression load, right? So where are you seeing this type of elements? This type of elements, bar element. So one dimension is a one dimensional bar element. If you take this fan, that is a one dimensional bar element. One dimensional bar element. It will take what type of load it will take? During rotation, it will take tension load. That's a centrifugal load. It will take axial tension load. Right? So this is a bar element. Right? It will not take any transverse load or torsional load. So this is one of the example of the bar element. Right? Then we'll go for a truss element. So can you explain what is this?
This is the truss element. Okay. When the load carries on the pin joint of this truss element, truss element will carry only the tension and compressive load because it does not resist the bending moment.
Bending moment. Good.
The applications of the truss element were used in bridges, roofs, and aircraft. It is a supporting member, sir.
Any other answers you know about the truss element? Okay. Any other answers? So application of truss element. Application of truss element. Building. So building bridges. Good. Cardboard design. Okay. So we'll understand what is a truss, right? Truss element which carries the what type of
Tension
and compression load, which is in its own axis. So it is a combination of the bar element, right? We have 2D truss and 3D truss elements, right? So once you see the bar element, the n number of bar elements which is joined by pin joint. So we know the bar element takes only compression and tension load. Similarly, this n number of bar elements we place in different angles and we are joining as a pin joint. So this pin joint is the important thing in the frame where the load will take place. That's why we are saying this as a truss element. Whereas the frame element, this is a frame. We say this is a frame element. Frame element it will carry even at the joint as well as the frame also. It will take transfer load and the joint. So here we have how many joints we have, how many elements we have. So we have 5 joints. 1, 2, 3, 4, 5 joints. How many elements? 1, 2, 3, 4, 5, 6, 7 elements. So what this structure is a stable and unstable structure. Is it stable or unstable? Is it stable? Once we are using joints, if we hold or fix it somewhere, the structure is stable. If it is not unstable, if you remove one joint somewhere, it will install. It will not make as a pressure. Right? So this is we'll understood the pressure element. Next we'll go for the beam element. So where someone say what are different types of beams are there? So what are the beams are there?
Simply supported beam, cantilever beam, point supported beam, roll supported beam.
So can you explain this and this number?
This is the structure of a airfoil beam. It is made up of different types of components into a single structure. The structure, these airfoil structures are called as ribs, and these are the stringers. The airfoil skin covers the upside of the ribs, which gives a smooth flow in that. And there will be a fuselage, fuel filling compartment, which is kept inside the kept in the wing. So there will be a gap inside the airfoil wing. So then we could balance our weight when the fuel is filled.
So this is the construction view of aircraft wing. It will act as a cantilever, right? Wings will be called as a cantilever. Here we will take two types of load. One is a structural load, another one is aerodynamic load. We know the aerodynamic load are lift, drag, thrust and weight. This is the aerodynamic load. Whereas in structural load, it has to be withstand all the engine weight, overall payload weight, right? It won't weight, it won't self weight. So this element has to withstand the stiffness. It has more stiffer than the other metal. It has to it has operated the elastic limit also. It should not twist. Right? We have to fix the engine in the shear center so that the wing will get only bending without twisting. For that we will understand here. Let us take this is a cantilever wing. This is a wing structure. Right? As an engineer, we want to mount an engine. For that we have to calculate. And we have to place that particular load. Let us take this is the engine load. This is the engine load. We need to place such that it should not twist. If I place here randomly, this wing element gets twisting. You can see the condition. It's getting twisting. Is it right? Yes. If I place here, it gets twisting its own weight. So I need to calculate the point. The wing should get bent, but it should not twist. So for that I need to calculate shear center and I have to fix the engine. Or else the wing get twisted. Right? So for that only we are finding the right position where it will get only bended, not twisted. So if you place this location, this wing will act as a bending alone, not twisting. So for that only we are finding the shear center. To find the shear center, we need to understand what is shear. So what is shear load? What is the shear stress? Then only we will make the wing element without twisting. So this is for the wing condition. Next we will go for spring element. So Riyash told that we have two different types of spring. We have a lot of the different applications of spring. Here we have closed coil helical spring. So can you explain what is how it is operated? Where you see this component? The application of spring. Application of spring. Where these springs will use generally? Cycles we use. All the automobile engines or vehicles will use spring elements. Then spring, where you see spring elements? Someone?
Cycle pumps.
Weightlifting spring balance.
Yes, okay. Weightlifting, spring balance.
Cycle pumps.
We have pens, pen wheel is spring. Motors, good. Pump, good. Cycle pumps, we use the spring elements. Wherever we have to reduce the vibration, especially wherever we have to use the vibration, control the vibration. That where suspension plays a major role. So this is the thing. So for that, this spring element will take the torsional role, either in a tension case or the compressor case. Right? This is a closed coil helical spring. For the closed coil helical spring, it has to use only in the tension load. Right? Whereas in the closed coil helical spring, it has to take compressor load. Right? If you see in the Duke bike, there we have the orange color spring in the back of the seat. Then it will take the compressor load. Whereas that the head position, seating position will be fixed, whereas the tire of the vehicle will be moving up and down. Right? So this is the thing we have to understand. In spring element, we will see the we have to see the how many torsion it has, how much stiffness it has, how much it get deflected. Right? These are the parameters we need to understand. Right? So we'll see the remaining section parts in next class. Right?
Welcome. What are the different type of spring used in the interface in automobile mobile sector?
Yes, sir. Two types of springs is there, sir. One is closed coil helical spring and open coil helical spring, sir. Here it is having the open coil helical spring. Here it will take the axial compressive load, sir. General structural elements, we have different types of structural elements. One is beam element, bar element, spring element, truss element, and frame element. Here we have the automobile car. Here we have the lot of structural elements are there. The sheet is there, and panels is there, and spring element for the suspension is there in inside. So from this we'll understand the importance of structural elements and usage of its application. The truss element, we have already discussed about the truss element and load carrying capacity of the trusses. It is the n number of the bar element and joint in a permanent joint. We'll see here we have the live example. Here we have the different truss construction which is closed the well. There we have the frames, structures as there.